Hi, I am Dr.V. Giridhar, Professor of Civil Engineering Department, KSRM College of Engineering, Kadapa. Welcome to the video lecture series 1. My topic is performance of strength and moduli characteristics of ceramic waste aggregate concrete. So, for the following contents are explained in the following series. First one is introduction to the concreting work and ingredients of ceramic waste aggregate concrete, need of the project, objectives of the project, behavior of the ceramic waste aggregate concrete in fresh condition, behavior, the performance of the strength characteristics of the ceramic waste aggregate, performance of the stress strain behavior of the ceramic waste aggregate concrete, conclusions and reference. These points are explained elaborately each and every point in the coming series. Introduction to the concrete. We all of us know that concrete is an inevitable material in human life, because in the 21st century central government has introduced industrialization policy. In this aspect, infrastructure development is increasing enormously in India. That's why almost all industrial areas, metropolitan cities and urban areas are occupied with a concrete jungles. So, concrete usage is increasing enormously in throughout the India. Due to this reason, we are unavailability of a quality of ingredients available for the concrete making. So, in this, coming to this production of the cement, nearly 329 million tons of cement is producing in our India. But the per capita consumption of the concrete is 2 kgs per capita in India. But whereas in the production of cement, per capita consumption of the cement is 195 kgs in India, which is so much of less than this compared with China, and they are using 500 kg per capita. So, it is slowly increasing the infrastructure development, the usage of the cement in our areas also. So, why this concrete is so uniqueness is due to this reason of unique characteristics as strength and durability characteristics. Now, normally the concrete is using from M10 to M60 grade of concretes in different applications of the structural elements. Ceramics are manufactured with basic composition of clay and other minerals, adding to this composition and dehydrated at a temperature of 1200 to 1290 degrees centigrade, and manufacturing the different type of ceramic materials in India. So, nearly 100 tons of ceramic products are manufacturing in India. Out of this one, 15 to 30% of the ceramic products are coming to the waste because of its unique characteristic of brittle nature and some porcelain nature. Due to these two reasons are influencing the development of a waste nearby the industries. And other ingredient using in the composition is fine aggregate. So, nearby the river sand is using nearby the Kadapa town and it is conformed into a zone 2. And finally, the water, the water is using from the local sources, that is nothing but it's a borewell sources are using in the preparation of a concrete composition, and even that can also used for the curing process of concreting elements. Due to this reason, so some research work is a necessity to replace the conventional aggregate. To meet the requirements of a conventional coarse aggregate, certain important things are required to add to replacing the conventional coarse aggregate. For this one, so in Kadapa is a Kadapa which is having a more number of industries. In these regions, ceramic in these regions, different type of wastes are developing in the industry nearby the industry. So, one of the basic waste from the industry is construction and demolition waste, marble waste, Kadapa stone waste and ceramic waste. Why I have chosen this ceramic waste industries means in Kadapa town itself we have 10 to 15 number of industries are working out on transformer units and electrical disk units. In each industry nearly 15 to 30% of the waste is mountaining up every day. So, due to this vast wastage, they are facing some difficulties into dump into a low-lying areas. But nearby the Kadapa regions, we don't have any low-lying areas, and its cost of the lands are also very high. So that's why they are facing a difficulty of dumping. And that's why in my experimentation I suggested reuse of these ceramic waste products into a concrete composition and make the new concrete composition and study the its behavior of strength and durability characteristics of this ceramic waste aggregate concrete in my experimentation work. We all of us know we have different type of ceramic products are manufacturing in India. One of that one is tiles, pots, sanitary basins, plumbing materials, electrical discs, electrical bushes in transformers and other materials are also manufacturing in India. Almost this figure 1 shows this production of the different ways in India. Out of this one, only few part of this one, that is 5% of the waste is recycled and used into manufacturing of the similar materials. But 75% of the waste is dumped into low-lying areas. So that's why that much of waste is not using properly. So in this process, we can use this waste into a concrete composition and make a new concrete composition for this society. Processing of ceramic waste aggregate. Actually, I already told you nearly 15 to 30% of waste is generated in the ceramic industries. So, I myself collected the waste products in transformer units. In that one, ceramic bushes are waste dump is available in Giridhar electricals and in nearby the Kadapa town. So, in this one, that much of a waste is developed due to the unique characteristic of brittle nature and porcelain nature. Every day the waste is increasing and they are facing certain difficulties to dump into the low-lying areas. So that the waste is collected from this Giridhar electricals and make this one into a process, make this waste processed properly and make it into a required size of 20 mm size and 12.5 mm size by manually. So during this manual crushing, almost 80% of the porcelain surface is gone away and compacted the clay materials in a ceramic waste products are coming out. So that much of that waste is used into a concrete composition. Why I have chosen these ceramic bushes are the thickness of the ceramic bush is nearly 20 mm and it is equivalent to the conventional coarse aggregate. That's why I have chosen this aggregate into a concrete composition. Characteristics of the ceramic waste aggregate. Normally, I already explained that the thickness of the ceramic bush is 20 mm. That's why I have chosen this one. And the size of the bush is 20 mm and make this one and into required size of 20 mm and 12.5. The shape of this ceramic waste aggregate is irregular shape. Even conventional coarse aggregate is also irregular shape of aggregates are using in a composition. Bulk density of the ceramic waste aggregate is 1000 to 1200 kg per meter cube. And the texture of the ceramic bush is covered with porcelain nature. During this crushing, manual crushing or a machine crushing, the porcelain nature can gone away and make this one which is useful for bonding process. And the specific gravity of the ceramic waste aggregate is 2.5. It is somewhat lower than the conventional coarse aggregate. The water absorption of the ceramic waste aggregate is 0.18%, which is slightly higher than the conventional coarse aggregate. And pore structure. Normally, this clay the content maximum percentage of the clay is using in the manufacturing of the ceramic materials, and it is compacted properly, and it is a crystalline nature, and this type of a pore structure is wide open during the crushing. That's why the water absorption of the ceramic waste aggregate is somewhat higher than the normal conventional aggregate. And bonding, so normally moderate bonding is we are observing with this ceramic waste aggregate. Objectives of the ceramic waste aggregate column. So we fixed up 4 objectives for this ceramic waste aggregate concrete in my experimentation work. The physical properties and mechanical properties of the ceramic waste aggregate. Whether this ceramic waste aggregate is suitable for usage into a concrete composition according to the IS 370 and 1980, that we have to find out. And the second objective is what is the behavior of the ceramic waste aggregate concrete in the fresh condition, and that was studied by conducting a slump and compaction factor test. And third objective is study the strength behavior of the ceramic waste aggregate concrete by a flexural test. So, by casting of a beam specimens and studied its behavior. And fourth objective is stress strain behavior, that is the moduli behavior of the Young's modulus of the ceramic waste aggregate concrete that is studied. So, these are the 4 basic objects I put for study this in this particular aspect of experimentation work. And next one is coming to this table 1. So, properties of the materials which used in a new concrete composition of ceramic waste aggregate concrete. In this one, I already told you cement, Dalmia 53 grade of cement is used in this experimentation work, and its specific gravity is 3.12, initial setting time is 80 minutes and final setting time is 280 minutes. And coming to the fine aggregate, so nearby the river Penna river sand, which is procured for experimentation work, and it's conforming to this one as a zone 2, and its specific gravity is 2.62. All these are within the, all these are compared with the IS code 370/1970. And coming to this coarse aggregate, so I already explained this importance of this coarse aggregate. So this is procured from Ramapuram Mandal from nearby the Kadapa town with a lead of 25 kilometers and procured for experimentation work, and its specific gravity is 2.64. And coming to this last ingredient, that is ceramic waste aggregate, and from this Shirdi Sai Electricals, I procured this ceramic waste aggregate, and its specific gravity is 2.5 and crushed into required size of 20 mm and 12.5 mm of different the graded aggregates are prepared for better compaction, for better workability conditions. I used these different grades into a concrete new composition. Let it be suitability of ceramic waste aggregate into a concrete composition. That has to be studied through this table number 2. In this one, the specific gravity of the coarse aggregate is between 2.6 to 2.8. But for the conventional coarse aggregate, I obtained 2.64. But for ceramic waste aggregate, it is 2.5. It is somewhat 5.6%, 5.6% of less I observed from this one. Water absorption of the conventional coarse aggregate is 0.1%. But whereas ceramic waste is 0.18%, that is somewhat higher than the conventional aggregate, because during the crushing, so the compacted nature of the clay materials which are wide opening, and also basic composition of this ceramic waste, so the water absorption is increases nearly 80% more than the conventional. But and third one is impact value. Normally, according to the IS 370, the IS 383 1970, its value has to be less than 30%. So for conventional coarse aggregate, it is 18.6%, whereas for ceramic waste it is 22. And similarly, the crushing value it is 15.3, and for ceramic waste aggregate it is 20%. Abrasion value it is 14.25, and ceramic waste aggregate 19%. Elongation index it is 26%, and for ceramic waste aggregate it is 18%. For flakiness index it is 24%, and for ceramic waste aggregate it is 15. Whereas coming to the bulk density, so this bulk density which is influencing the density of the concrete, so specific gravity and bulk density both are important factors to study the bulk density, to study the density of the concrete. So in a loose conditions, natural conventional concrete is 1219 kg per meter cube, and in a dense condition it is 1425. For coming for the ceramic waste aggregate, it is 1069 and 1198 kg per meter cube. It is somewhat lower than the conventional aggregates, that is 12.3% and 16.6%. So both are within the limitation. So as compared to the entire table of 2, and almost all the mechanical properties of the ceramic waste aggregate are within the range, and those are suitable for usage into a new concrete composition, that is a ceramic waste aggregate concrete. Quantities of ingredients in a new concrete composition, ceramic waste aggregate concrete. For this one, prepared the mixed design according to the availability of a material properties, and I concluded this proportion is 0.48 is to 1 is to 1.53 is to 2.88. So 0.53 stands for water cement ratio, 1 stands for cement, and 1.53 stands for sand, and 2.88 is coarse aggregate. In this coarse aggregate, replacement of a conventional coarse aggregate with the ceramic waste aggregate at 0 to 100%, 0, 20, 40, 60, 80 and 100%. This percentage replacements is introducing in a new compositions and study the its behavior in fresh and strength aspects of the ceramic waste aggregate concrete. So this table 3 which representing the quantities of a ceramic waste aggregate. In this one, so the nomenclature R stands for reference concrete, that is conventional concrete, and CWAC stands for ceramic waste aggregate concrete at a replacement of a 20. That means coarse aggregate is replaced 20% in a conventional coarse aggregate. Like this, I have taken 6 mixtures and replaced the ceramic waste aggregate from 0 to 100% instead of this coarse aggregate. So next one is, we already studied the behavior, the physical and mechanical properties of the ceramic waste aggregate, and all aggregates, the ceramic waste aggregates are within the range according to the IS 383 and 1970. The suitability is good for usage into a concrete composition. And this second objective is study the behavior of the ceramic waste aggregate concrete in a fresh state. For this one, so we studied the workability test like a slump test and the compaction factor test. In a slump test and a compaction factor test, in both the tests, the important factor is homogeneity. So cohesiveness and cohomogeneity both are influencing. Actually, in the process of mixing processing, the water absorption of the ceramic waste aggregate is somewhat higher than the conventional aggregate, but whereas in a mixers, as I explained in table 3, so the water cement ratio is uniform, that is constant, but the water absorption of the ceramic waste aggregate is more. So due to this one, the homogeneity which is not up to the mark, due to this reason, the slump values and the compaction factor values are slowly, gradually decreasing, and that can be explained in the next coming slide. So these two photographs which is representing slump of the ceramic waste aggregate concrete and compaction factor of the ceramic waste aggregate with all different replacements of new composition. In the analysis of fresh concrete of ceramic waste aggregate concrete, so from the table I already explained that slump value is slowly decreasing. So for a reference concrete, slump value is 120 mm, and if the replacement is increases to 20 to 100, so the slump value is gradually decreased to 82%. And similar type of trends we observed even in a compaction factor also. For a reference concrete, the compaction factor value we obtained as 0.92, and it is slowly decreased when the ceramic waste aggregate replacement as 100 and its value is 0.75. Both the figure 8 and 9 representing the slump value and compaction factor values when the replacement is increases. In x-axis it is representing the percentage of replacement, in y-axis it is representing the slump value and compaction factor, and by observing these two figures, so slowly it is decreasing due to the so many reasons. In study of results and discussions of the ceramic waste aggregate concrete in fresh condition, actually I already explained that as the replacement level is increases, the value of a slump and compaction factor is reduces. There are so many reasons are influencing. One of the best example for decreasing of this one is specific surface of the ceramic aggregate. So it is irregular shape, and almost 70 to 80% of the surface is fade out of porcelain nature. Due to this reason, water absorption is increases, and also during the crushing, the compacted nature is turned up into a slight cracks are developed during the crushing. This reason also influencing the increase of water absorption of the coarse aggregate. And the third major point is the basic composition of the ceramic waste aggregate. So the basic composition is clay. Normally clay can have the property to absorb the water. Due to these three reasons, the ceramic waste aggregate absorbs higher water absorption than this one. The specific surface of the ceramic waste aggregate is also increases. So due to these two reasons, the specific water absorption is increases. Due to the lesser water absorption, the homogeneity and the easiness of workability we could not obtain in this experimentation, but it is up to a certain mark and we can use this one, and up to a certain mark and we can use this composition into the different applications of the concrete elements also. Especially normally this ceramic waste aggregate concrete is using in the PCC works. The PCC work and non-structural members, we can use it. So the third object is stress strain behavior of the ceramic waste aggregate concrete, that is moduli characteristics. Normally concrete is not a true elastic material, and it is a little brittle material. So the Young's modulus of the concrete is studied the slope of the chord at any point from the graph. So this is the figure 10, which is representing the diametrical representation of the stress strain behavior of the conventional concrete. So in this diagram, so we can study the Young's modulus of the concrete with different methods. One is with the initial tangent method, and tangent modulus method, and secant modulus method. Out of these three, secant modulus is more familiar than the other two methods. But in my experimentation work, I studied initial tangent method, so that can gives a little variation values in my experimentation work. For this study of a stress strain behavior of a concrete, it is mandatory to prepare cylindrical samples with a size of 150 by 300. Normally for each composition, that means for each replacement, 6 number of samples have to cast, and out of these 6, 3 samples have to test the cylindrical compressive strength, and remaining 3 we can fix up the extension of the compressometer with a dial gauge of 0.002 by 5 mm, and that can be fixed at a gauge length of 20 centimeter. The height of the specimen is 300 mm and the gauge length is fixed as 200 mm. And dial gauge has been fixed for this experiment and placed this specimen in a compressive strength testing machine and properly compacted the top and bottom surface of the cylindrical specimens, and test performance has to be adapted and calculated the stress strain behavior of the different ceramic waste aggregate concretes and reference concrete. As per the IS 456-2000, so normally Young's modulus of the concrete is calculated with 5000 under the root of FCK. That FCK which is representing that is characteristic strength of the concrete. And similarly, as per the BIS 8110, that is calculated 1.7 into 10 to the power of -6 rho square into the FCU to the power of 0.33, whereas FCU is nothing but cube compressive strength. Already cubes are cast and tested its crushing values for different replacements. And according to the as per the ACI 318, so the Young's modulus of the concrete is calculated 0.043 into rho to the power of 1.5 and FC to the power of 0.5, whereas here FC is calculated, that is cylindrical compressive strength of the concrete, where this rho is representing the density of the concrete with different replacements. Experiment has been followed in stress and behavior of the concrete is by fixing the compressometer. I already explained earlier. So, by increasing they placed this specimen in a compressive testing machine and increase the load 100 for every increment of 100 kilonewtons and record the deflections from the deflectometer. With the help of these two parameters, calculated the stress and strain and find out the final Young's modulus of the concrete with different replacements. So, this table 4 representing the stress and behavior of the ceramic waste aggregate concrete with different codes. So, the replacement is followed from 0 to 100 and the experimental values which obtained from the this one as 35 to 26 as the replacement is increases. So, the same values, the same thing we can calculate as per the IS 456-2000, its values are changes from 30.43 to 28.35 gigapascals. Whereas for BIS 8110, so its value is 33.22 to 28.93. And according to the ACA 318, its values are 29.6 to 22.76. So, the density of the ceramic waste aggregates are also calculated separately and tabulated in the tabular form, and compressive strength of the cylindrical specimens and compressive strength of the cube specimens are also tabulated, and those are used and calculated the stress and behavior of the ceramic waste aggregate concrete in a different codes, and which is representing that variation is representing in the figure 13. This table 5 which is representing the experimental values by incrementing of loads from 0 to increment of 0 from 0 to 100 and 100 to 220 like this. We can increase the increment of 100 kilonewtons and take the deflections substantially and calculated and draw the graph and calculated this entire experimental values in this particular aspect. So, this is figure 4 representing the stress and behavior of the ceramic waste aggregate concrete in the different replacements. So, all these graphs are representing the Young's modulus of the concrete is representing these curved lines. So, I already explained that. So, in nowhere the Young's modulus of the concrete is straight or constant. It is parabolic, just like it's a parabolic arch we obtained from the experimental results. So, that is more or less within the range of the stress and behavior of the conventional concrete. And what is coming to the results and the discussions of the ceramic waste aggregate concrete is, so there are so many parameters are influencing the stress and behavior of the ceramic waste aggregate, especially the aggregate mechanical properties like impact value, crushing value, abrasion value, and like this, those are much more influencing the properties of the stress and behavior of the ceramic waste aggregate. And presence of moisture content is also one of the reason for influencing the stress and behavior. So actually, by analysis of the obtained result, say the modulus of ceramic waste aggregate, which is decreased to 25.7, as the replacement is increases from 0 to 100, it is 25.7% only. So that is less than the 30%. So hence we can use this, we can use up to a replacement of 40% into the concrete composition, and that can be used into a non-structural members like PCC and other elements. So next objective is flexural strength of the ceramic waste aggregate concrete according to the IS 516/1959. So normally flexural strength is one of the important strength aspect in the study the behavior of the concrete. So for this one, 2-point loading system is carried out to study the flexural strength. Normally the flexural strength is influencing by the aggregate properties, particle size of the aggregate, texture of the aggregate, size of the aggregate, shape of the aggregate, and extent of hydration is also influencing this flexural strength. Normally in the process of calculating the flexural strength, we can use this the formula FB is equal to 3 into PA divided by BD square. P is the load and A is the extent of area which crack is developed from the extreme fiber. So these two figures, that is 15 and figure 16, representing the 2-point loading system. In this one, so the size of the beam which is cast as 150 mm by 150 mm by 700 mm. This is the standard size of the beam size. And out of this one, the testing operation has to be carried over for 150 by 150 by 600 mm only. So for this one, we can transfer the loads through 2 rollers which are provided over the specimen, and slowly we can increase the incremental loads and calculating the observing the behavior of this beam. Normally, if you are increasing the load, the cracks are developed from the bottom fiber. Cracks are developed as that was shown in the figure 16. So from the bottom figure, cracks is developing and slowly it is propagated into the compression zone, and finally without warning, the specimen can split into 2 pieces. If we are, that was happened due to the unreinforcement of this specimen. In these specimens, we are not provided any reinforcement. That's why without a warning, so the specimen has to be broken into 2 pieces in this experimentation. So loads are calculated and sectional areas are known, and the values are tabulated in table 6. In this one, the values flexural strength of the ceramic reference concrete is 5.72 megapascals. As the replacement is increases to 100, its value is decreased to 3.60. So that similar values which are representing in a figure, that is 17. So that figure representing slowly flexural strength of the ceramic waste aggregate is decreasing. So there are so many reasons which are influencing for decreasing values. So one of the important factor for decreasing the value is improper bonding. So then there is the proper bond has to be developed between the coarse aggregate in the cement mortar. But the ITZ is in a ITZ, interfacial transition zone, there is a lack of bonding. Why? Because the ceramic aggregates are having a porcelain nature. Due to this one, so the bonding is not up to the mark as compared to the conventional concrete. And the second reason is due to the unreinforcement. So, in that in this specimen we are not provided any reinforcement. So, it is a PCC specimen. So, that is why it fails suddenly. So, that is also another thing. And third one is brittle nature of the ceramic waste. So, normally the unique the characteristic of the ceramic waste is brittle. So, that is also influencing the sudden failure of the specimen in this concrete composition. So, as compared to the cracks, I already explained that cracks are developing from the bottom fiber to top fiber, and that too these cracks are developed below the roller or between the extreme fiber to the below the roller. So, these cracks are developing and sudden failures are observing. As the analysis of these above results, as the replacement of a ceramic waste aggregate at 100%, the percentage of decreasing value is 36.5. But in the analysis part, so we can recommend to use the ceramic waste aggregate concrete into the concrete composition of 40%, and its difference of decreasing value is only 8%. Hence, it is ideal to recommend to add 40% of the ceramic waste aggregate concrete into a new concrete composition. Based on the above experiments, so I conclude a few points in the given slide. That is, after doing of all experimentation work, I found that the ceramic waste aggregate is suitable for usage into a concrete composition. Normally, the properties of the ceramic waste aggregate is not same with the conventional coarse aggregate, but it is somewhat lower than the conventional aggregate. But within the range of aggregates according to the IS 383 in 1970. And it has a higher water absorption. This ceramic waste has higher water absorption, that is 0.18% as compared to the conventional aggregate of 0.1%, because it is a irregular shape, higher specific surface, and basic composition of a clay, and cracks are developed during the crushing. These points are influencing to increase of high water absorption. So, that is why, and normally the maximum content of water absorption in a coarse aggregate is less than 5%. So, it is within the range and it can be suitable for added into the concrete composition. Coming to this replacement of a ceramic waste aggregate in a stress strain behavior of the concrete. So, it is ideal to replace 20%, because the percentage of declining is only 8.6%. That is why it is recommended to add only 20% of the ceramic waste aggregate whenever we are going to do the test of stress strain behavior of the ceramic concrete. Whereas coming to the flexural strength of the concrete, so we can recommended this 40%. We can recommended this 40% of the ceramic waste aggregate into a replacement level, and its value of declining the strength of the flexural strength of the ceramic waste aggregate concrete is only 8%. So, we are recommended to add only 40% into the concrete composition. These are the basic conclusions which I referred for this one. And furthermore, so in the future scope of the work, so we can follow up to cast the slab specimens and to study the microstructural analysis that will helpful to suggest adding of the ceramic waste aggregate into a composition or not. So, that is further scope of work which is left over in my experimentation work. And coming to this one, the following references are followed, and study the all references and the literature review. Through this literature review, so we concluded the percentage of replacements and the percentage of replacements for different experimentation work that studied and suggested up to a certain value of percentage replacements. Thank you very much for patiently for listening of my video lecture. And once again, I am thankful to the Managing Director, Dr. Chandrababu Reddy Garu, Principal, my HOD, so for giving this opportunity for making this video lecture series 1. Thank you very much.